Section 5.4, Properties of Rational Functions. Recall the important restriction on the value of the denominator in a fraction. We remember that the denominator of a fraction cannot equal 0. Well, this also applies to fractional functions, and we call fractional functions rational functions. Remember, rational, fractional, they kind of rhyme. So we remember that rational functions are functions that contain a variable in the denominator. So here are some examples down here. Here's the example of a rational equation that we've solved in a previous algebra course. So if we look at this example, if you guys remember, if you solve this equation, you'd have to check your answers and make sure that when you plug them back in, they wouldn't cause the denominator to become 0. So in this case, if we set 3x minus 1 to 0, we get x equals 1/3. So that means there's no way x can ever equal 1/3. X cannot equal 1/3 in this equation. And then if we set the other denominator, x, equal to 0, so that's telling us x cannot equal 0, or else it would cause this function to be undefined. So I'm going to call these values that make the denominator of a function 0, I'm going to call them the excluded values. So it follows then that the domain of a rational function is all the real numbers except these excluded values. These values that make the denominator equal 0. So we'll look at some examples here. Example 1a, we want to find the domain of this rational function. So remember, rational function, and actually let's make a little note up here. Just when you think rational, I want you to think fractional functions. Okay, so part A, r of x equals 5x over 3 plus x. So in order to find the domain, all we care about is the denominator, because that's the only restriction that would cause a restriction on the domain. So if we set our denominator to 0, we're going to get an x value of -3. So that means that we're going to exclude -3. -3 is the excluded value of this function. So when we write our domain, pay attention in my math lab how they ask you to write it. But in set notation, it would be the set of x's such that x does not equal -3. Or in interval notation, a way of saying everything except -3 would be -infinity to -3, union -3 to infinity. So either one of these is correct, just depending on how they want the answer written. So now let's look in the table. Let's look at this on the calculator. If we enter this function 5x over 3 plus x. Now a couple things. When you enter rational functions, we always want to include the entire numerator in parentheses and the entire denominator. So in this case, the numerator, 5x, it's only one term, excuse me, so it wouldn't actually matter here if you put the parentheses around it, but it's a good habit to get into. If you put parentheses around it, it'll never be wrong. Because if in the denominator you have two terms, you have to put the parentheses around it, or else it would be incorrect. So get in the habit of parentheses around the entire numerator and parentheses around the entire denominator. So if we look at the table, we're going to see at -3 an error for our y value. And that makes sense because we just found out that an x value of -3 would cause this denominator to equal 0. So you guys can try the other two parts of this example 1.